So hello, and welcome to our first lecture dealing with nomenclature for compounds. We're going to be talking about the nomenclature of both molecular and ionic compounds. When we react the elements together, we form compounds. And broadly speaking, we divide compounds into two groups: molecular compounds and ionic compounds. The molecular compounds exist as their molecules, in the same way that any amount of an element is simply some number of atoms of that element. Any amount of a molecular compound is simply some number of molecules of that compound. Water is an example of a molecular compound. It consists of two hydrogen atoms bonded to one oxygen. And any amount of water is simply that same arrangement of atoms over and over and over again. Any amount of water is simply some number of water molecules. Ionic compounds, on the other hand, are formed of ions. They have to include both cations and anions. They have to include both cations and anions because you can't make electrically unbalanced compounds. You have to always balance the charge. So the charge between the cations and the anions has to always cancel. Sodium chloride is an example of an ionic compound. In sodium chloride, each of the sodium ions wants to surround itself with chlorides, and each of the chlorides wants to surround itself with sodium ions. And so we get a structure that has this kind of every other spot arrangement, where the cations alternate with the anions in the structure. And each of the sodium ions ends up with 6 anions around it, and each of the chlorides ends up with 6 cations around it. And the ions like this arrangement a great deal. But this brings us to a significant difference between the molecular and the ionic compounds. In the molecular compounds, the atoms are actually bonded together and do what is known as covalent bonding, which is a sharing of electrons. In the ionic compounds, the ions are only attracted to each other. They're not actually bonded together. So unlike the molecular compounds, there is not a single unique obvious piece for the ionic compounds. At the smallest level, we have two clearly different pieces. The cations are clearly different than the anions. So in this case, we don't have molecules. We have what is known as a formula unit. We have two requirements for a formula unit for an ionic compound. One, it has to be neutral. We already said that. All compounds have to be neutral. And second, it has to be the fewest of the ions present that give you something neutral. So 1 chlorine and 1 sodium would be neutral. 2 chlorines and 2 sodiums would be neutral. 6 chlorines and 6 sodiums would be neutral. But only the 1-to-1 is both neutral and the fewest numbers of ions. And so we talk about formulae. Which brings us to nomenclature, the naming of compounds. And the first rule of nomenclature is that a name must identify a single unique compound. The whole point of using the name is so that you know what compound you're talking about. If a name identifies several different compounds, then using the name does not in fact tell you what you are talking about. And so the first rule of nomenclature is that a name must identify a single unique compound. We could name compounds by simply giving them a basically arbitrary name. Things like acetone and benzene and toluene. And this is known as trivial nomenclature. And the problem with doing it that way is that would require you to name and memorize the formula for every single compound. And since at last count there were something like 6.5 million different compounds known, that would be an enormously long list. So we don't assign names arbitrarily. We try and assign names systematically. so that the names actually tell you something about the material. If you take nitrogen and oxygen, you can chemically combine them to form compounds. You can, in fact, form these 5 compounds. And the point is, we have to have some way of distinguishing which they are and which is which. Now, we're not going to just assign them arbitrary names. We want to assign them names that actually give us information. That is, we want to use a systematic form of nomenclature. The first rule for naming a molecular compound in the systematic nomenclature is to name the elements that are present. Usually, the further to the left and the further down a column is, the earlier it is mentioned in a formula. The further to the right and the further up it is, the later it tends to be written in the formula. For our 5 compounds, therefore, the nitrogen is written first, since it is to the left of oxygen on the periodic table, and the oxygen gets written last. The first step in naming these compounds is, therefore, to write nitrogen and then oxygen, nitrogen being first, the oxygen being second. But of course, all 5 of them can't be nitrogen-oxygen because they're all different compounds. And so we have to do something that distinguishes the 5 different compounds from each other. The obvious difference about the formulas is the number of atoms they have in each one. And so that's the important information. We have to use Greek prefixes to distinguish the number of atoms of each type in the compound. The prefix for 2 is di, so the first compound starts out as dinitrogen. The prefix for 1 is mono, and so the oxygen gets a mono. But since oxygen is starting with a vowel, the mono loses its last vowel, and rather than mono-oxygen, it's monox instead. For nitrogen, for the second one, the nitrogen gets the mono and the oxygen gets a mono. The next one, the nitrogen gets a mono, the oxygen gets the di. For the fourth one, the nitrogen gets the di, and there are 4 oxygens. The prefix for 4 is tetra. And finally, the last one, again, the nitrogen gets the di, and the oxygen gets the prefix for 5, which is penta. The last step for naming a molecular compound is you take the last element, whichever one is written last in the formula, and change it and give it an IDE ending. So in this case, the oxygens all become oxide. And so our 5 compounds are dinitrogen monoxide, mononitrogen monoxide, mononitrogen dioxide, dinitrogen tetroxide, and dinitrogen pentoxide. And that is the systematic way for naming molecular compounds. Now often, when there's exactly one of the first one, people will tend to leave the first mono off. And so you would see the second and third ones most commonly written as simply nitrogen monoxide and nitrogen dioxide. But technically the monos should be there. But like I said, people often leave them off. And those are the rules for naming simple molecular compounds. The rules are somewhat similar for naming ionic compounds, but they are different, and it's important to keep track of the differences. When sodium loses an electron, it goes from being an atom to being a cation, a sodium cation. Calcium loses 2 electrons and becomes a calcium plus 2 ion. Aluminum loses 3 electrons and becomes an aluminum 3 ion. Chlorine, on the other hand, is a nonmetal. Unlike the metals, which tend to form cations in their compounds, the nonmetals prefer to form anions when they can. And so a chlorine atom becomes a chlorine anion by gaining an electron. And you now refer to it as a chloride. And this is something to keep in mind. Chlorine is the element. Chloride is the ion. And unfortunately, that's a problem, because we said the molecular compounds also use the IDE ending. And this is a problem in the nomenclature. And they really should change one or the other of those endings. But they haven't yet, and so you just have to live with it. You see compounds that are both molecular and ionic that end in IDE. So you can't go by the IDE ending. Sulfur, another nonmetal, also wants to pick up electrons, but it wants to pick up 2. So a sulfur atom gains 2 electrons and becomes a sulfide ion. Nitrogen wants to gain 3 electrons. So a nitrogen atom gains 3 electrons and becomes a nitride ion. So what compound are we going to form if we combine sodium and chlorine? Well, what ions are we going to end up with? Well, we said the sodium atom is going to become a sodium cation in the reaction. It's going to lose 1 electron. The chlorine atom is going to gain 1 electron and become a chloride. So those are the ions we're going to have to combine to form our compound. And so what is the fewest number of ions of +1 and -1 that will form a neutral compound? So our formula should be written with the sodium first, the chloride last, since the sodium's the cation and the chloride's the anion. And usually, as we said, people tend to leave out the ones when there's exactly 1 of something. And to name the ions, it's sodium chloride. The cation first, the anion last. What's the formula for the compound we get by combining calcium and fluorine? Well, the calcium, an alkaline earth, forms a +2 cation in its compounds. The fluorine, a halogen, wants to form a -1 ion in its compounds. But if we use just 1 of each of those ions, we end up with something that has a positive charge on it, because the calcium has a +2 charge, whereas the fluoride only has a -1. And like we said, you can't make chemically unbalanced compounds. And therefore, we have to balance the charge. And the easiest way to do that is by adding a second fluorine. And so, for each calcium +2 ion, we're going to have 2 fluoride ions. And so we end up with calcium fluoride. Should that be calcium difluoride? And the answer is no. In the ionic nomenclature, we only indicate the ions present. We do not indicate numbers. Indicating the numbers using a Greek prefix indicates it's a molecular compound, and these are clearly ionic compounds. What compound are we going to form when we combine aluminum and sulfur? Well, again, the question is, what ions do aluminum and sulfur form? Aluminum, in its compounds, forms a +3 cation. Sulfur, in its ionic compounds, forms a -2 sulfide ion. So the compound we're going to get is aluminum sulfide. But what's the formula for aluminum sulfide going to be? Well, the problem is we have to balance the charge. And what's the first number that includes both 2 and 3? And the answer, of course, is 6. So to get a +6 from the aluminums, we're going to need 2 aluminums. To get a -6 from the sulfurs, we're going to need 3 of the sulfur ions. And so we have our formula for aluminum sulfide. And that concludes our discussion for today on the nomenclature of naming compounds. Go have a nice day.